We are recording. All right. Hi, everybody. Welcome to another Tempo community call. So it's been about a month since the last one, so we do these every month. And I'm not sure if the chat, how well it's shared, but we do have a shared, there's a link shared for the kind of Tempo community called to public document. And we'll just start kind of covering things. If anybody has anything that they want to talk about, just chime in at any time or add it to the agenda. We can cover that. And of course, we can talk in Slack and things too. Cool. Okay, so first thing that we wanted to talk about is we do have an Observability Con coming up soon. It's next month. And so that is, it's November 8th to 10th, and there will be a session on getting started with Tempo. And so don't miss that. And hopefully, there will be some cool things that we talk about there. And there's some links to those in the community document. Cool. We have the next big kind of thing is we have Tempo 1.2 upcoming. So we're kind of hoping to release that here in the next couple of weeks by the end of the month. And there's some really cool features in here. So we'll kind of just go through and talk about them, and then we'll see where we go. So the first one is ingester search. So this is being able to search recent traces. This is something we've kind of been working on for a while. So it's, we've gone through it on previous community calls, and of course, we've talked about it in Slack and things like that. But I can go ahead and just kind of like start sharing a window and click around things, and then we can kind of just show you, where we're going with it. We can talk about all that kind of stuff. That sounds good. Cool. Yeah. All right, cool. Yeah, so can everybody read that? I'm not, does it look like it's a good size? We'll go ahead and maybe resize it a little bit. So beforehand, we kind of just shared screenshots of this, but this is just running locally, so we'll go through it. So what we've added is kind of like a tag-based ability to search the recent traces. These are traces that are in the ingester. So if you know about Tempo's kind of internal structure, the ingester is what receives the data, and it buffers it for a little period of time and flushes it to disk, and it's responsible for flushing it to the back end. This is a Grafana, we've added a new tab here this is an experimental Grafana UI that's for this. What we're doing with it is kind of like, if you've used Jaeger, this should be familiar. So it's kind of have some drop downs here for kind of like the top level service name and operation. And then we have some tags and some other abilities to filter here. And so we'll go through that. And what I'm running here is the Tns Demo. So the Tns Demo is kind of a 3-tier application. Actually, it might be good to go and click on that. It's just a little toy 3-tier application with some different latency and some other services. So there's a load balancer application database. Cool. So just so we kind of know what we're working with here. And so if I just run the query on an empty thing, this is just a default search with no filters. So this will just start grabbing the quickest traces out of memory. And so we can click on some of these, and each of these are links to open the trace and explore window. There's some summary information here, when it started, the duration, the service, the top level service name. Cool. Yeah, and so the first drop down here is to filter by service name. And so this will find any trace with that service in it. So I can run that. Now for this TNS application, this demo, they pretty much all have that. So there's not really anything cool going on there, but there is a little bit of different stuff that we can do. The second drop down is the span name. So Jaeger calls this operation, but in OpenTelemetry, it's actually just a span name attribute. And we can click on some of these things and see, and this will find any trace with that data. And of course, they pretty much all have the same, but there are a couple of things here. So one, we can maybe look at, this is a different kind of request that's going through the system. So this is a polling metrics request. And so the span name is right here, HTTP get metrics. So what we're looking through here is really any of these attributes that are there's two levels in the OpenTelemetry standard. There's data at two different levels. One is the span level. These are tags. They're called attributes, but we're calling them tags. And these are unique to each span. And then there are process level attributes, which are more like part of the pipeline or the application itself. Service name is a common one. So this is set in your application, and other things like this part of the pipeline, like if you're using the Grafana agent or another collector, they can automatically add other tags like pod name, maybe the cluster and the namespace for their Kubernetes namespace. I don't have that here. This is just a Docker Compose kind of like setup. So cool. Yeah, we have a question here. Are the span names and other searchable attributes filtered off the service name or each other? So no, so they're not. So this will find any trace with any of these anywhere. So they're not actually tied together. So it's not looking at the span level. That is something that I think we're going to look at, because this is really useful. And long term, we definitely will be taking this more to a span level whereas right now it's just trace. Cool. So yeah, I think a lot of that will be like coming later, and we can talk about that a little bit. So other things we can look for, let's see, is this, the tags is more free form, and I'll get to that question in just a second. The tags are our ability to search all the attributes that are in here, and it's a little bit more free form. So we could do host name, and there's some autocomplete here, and we can do things like this, right? And we can combine attributes here that we want to look at. Yeah, so we can click on some of these things. Minimum duration. So this is using the Go timestamp formats here. And so, or sorry, duration formats. So we can do minimum format, we can do minimum duration, maximum duration. Yeah, so let's see. So error equals true. That actually does not work. So we actually need to fix that. So because error, the conversion, so Jaeger uses an error tag, like just a tag. In OpenTelemetry, it's a span status, and we're not actually capturing that yet. So we need to. Error, maybe we could create a virtual error tag out of it. That would probably be good. Let's make a note of that. Let's see, cool. Let's see, let's go back. So the other question was, are the suggestions in the dropdowns driven by data in the ingesters as well? Yes, so these dropdowns are actually coming from the data in the ingesters. So they are inspecting all the unique values that are coming out of the data as it's received. And it's stored for a certain period of time, and a tag that stops being present when it's flushed from the ingester will no longer be in the list. Yeah, so this list, it's not exactly what's stored in the ingesters, but it would be recent. Yeah, we're close. Cool. Yeah, so I mean, this is totally dynamic. There's no need to configure that, if that makes sense too. Yeah, so this is really a first step. So let's go with, we've shown this before, but this is kind of like the approach that we're taking for going with this feature. There's kind of three phases here. Phase one is what we're talking about now. And it's an API, the ability to search the ingesters and kind of this experimental Grafana UI. And what the next phase would do is kind of full backend search, and that's something we're looking at. And we might need to change directions a little bit. This we've learned a lot with this ingester search, so we've kind of looked at this certain data format, flat buffers, which has no penalty for decoding. The format on disk is the same as in memory. It's very fast, and it's good for brute forcing search. But for backend, we think it may not still be enough. So there's some things we want to look at there. And then at the same time, we're kind of developing a real query language. So we really want to do something that's really flexible and robust, kind of like PromQL or Loki QL. And that's kind of in progress. And so when that comes, like we'll have the full features, but what we didn't want to do is try to kind of, put a lot of that in here and kind of maybe set expectations for what the language could do or what, because we want to make sure that what we come up with, can be implemented in it and it's going to work well. So I think this is kind of like, basic experimental. I think it's useful, but yeah, it's still experimental. Cool. Any other questions or thoughts on this kind of stuff? So it will be in Tempo 1.2 as an experimental feature, so you'll have to enable it. So there are two ways to enable it, either a YAML config option or a command line option. And to kind of like in the release notes, we have some more information, but certain components of Tempo, if you're running in distributed mode, have to have it enabled, and other ones just don't matter, like the compactor doesn't do anything with it. Now the Grafana image for this feature, there is a feature toggle to turn on this tab, and it's the image that it's in. So I'm actually down here, I'm not sure if you can see this, but it's actually the latest 8.3 pre-release. That's probably the best thing to use because it has the most recent fixes and other things. But I understand an 8.3 pre-release might be a hard sell or hard to use in your environment. It's very, very new. There are some forms of this in 8.2 that are, but I can't remember the details about like if it's, how stable that is, but it is in 8.2 as a feature toggle and 8.3. Cool. Yeah, all right. Yeah, I think, hey, Kunrad, is there anything else that we should cover in here, or do we get through it?
No, I don't think so. I think this covers basically everything. We also got some interesting questions. So.
Yeah, the TNS demo data is not, particularly exciting, but there is some, it has a little bit. We are running this in our own internal cluster, which is 1.5 million or 2 million spans per second. And the data there is a lot more interesting, but we were hoping maybe to use that for the demo, but there's a little bit too much stuff in there. So yeah, but yeah, so there are a couple other little things that are search. I guess that we could mention some little features, but there is the ability to control which of these tags are actually recorded in the data. So if you have certain tags that are low information, like they can be kind of ignored and then they won't be searchable, like this one, the exporter version and maybe the client UUID. I think I might not have this set up for my local demo, but things like that, that may not be useful. So you can actually save a little bit of resources by doing that. Cool. All right. Cool. The next thing we want to talk about in 1.2 is a new mode for Tempo. So this is something that a lot of people have asked for, and it's really cool. I guess Zach isn't here, but he would know more about this. But so there are 2 ways to run Tempo, and soon there will be 3. So the 2 ways are single binary, which means it's just a single instance of Tempo. It runs everything. It has all the endpoints, it does all the compaction and the ingestion, everything. So but it doesn't scale. So it's just a single pod by itself. It doesn't get into a ring and network with any other pods. So that's what I was using here for this demo. The other way is a fully distributed. So this is where you're running separate deployments for queryers, query front ends, the ingesters, the distributors. And that way you can kind of individually scale, right, each kind of layer of Tempo. Well, we've kind of there's been a lot of interest in this third mode, and so this will be available in 1.2. It's called Scalable Single Binary. So it's like the single binary where each Tempo runs all components, except it's a single deployment and every pod still runs all components, but they will talk in a ring. And so that should be easier to deploy than the distributed mode. And so that's really good for people maybe that have outgrown the single binary, but maybe don't want to invoke all the different stuff for the distributed mode, because that's probably 10 times more work. And so this thing is kind of in the middle. So I think that's really cool. Now we're not using it ourselves internally. So, if you give it a shot, like we would be interested to hear about it. And so it's a little interesting because maybe when traffic comes in for a pod, like for the distributor, it actually will be talking to the ingesters, or let's say the query front end will be talking to a querier, which may be itself. It's kind of interesting, or it could be any of the rest of the pods. So it's kind of like more of a very interesting mesh and different performance characteristics maybe that we're not sure. But yeah, so that'll be out there. And there is a Docker Compose demo that kind of shows how to do that. Cool. Okay, so there's another, I guess I could be linking these PRs, but they're in the document. So the next thing that we think we wanted to talk about was, oh yeah, cool. So currently Tempo, if you run a query and it has an error on a block, it will actually just fail the whole query. So if you're trying to look up a trace, but you have a corrupted block in your backend, it will actually just fail the whole query. And so we know that's come up, you know, for certain people that are using Tempo. It's happened. You know, I think it's gotten us to probably everybody, where you have to go in and figure out what's wrong with the block and probably just delete the block. So what we're doing is this partial block results. It's a way to kind of smooth over this edge case. So if there's a corrupted block, right, we'll go ahead and return the results that we can. So Tempo already, if a trace is kind of spread out in multiple blocks, it already kind of combines that and unifies the trace and shows you what it can load. And so this is the same thing, but it can tolerate some block failures. And I think, hey, Mario, will there be a kind of like a new, we kind of want to show something in the Grafana UI when that happens, right?
Correct. Yeah. I don't think it's merged yet. Yeah, but we will be working with Grafana. So yeah, when we communicate that some blocks failed and it may contain partial results, that we notify the user that what they're reading is possibly incomplete. There is an issue opened. I will look for it and link it in the agenda.
Cool. Yeah. Yeah. So I think this is. Do you remember if there's any config options for this, or is this just always on?
Yeah, it's a new flag on the, well, like a new config param on the query frontend. I think it's called tolerate failed blocks. By default is set to 0, so the same behavior is maintained from before. So if any block fails, it will just fail the entire query. Yeah, but you can set it up to as high as you want.
Cool. Good. Yeah, it's probably most relevant for larger installations, maybe with tens of thousands of blocks, just because the chance of a failure in one of them increases. Yeah. Cool. Okay. Yeah. Okay. All right. The next thing is, so we have a PR here linked for kind of like the search backend work. If you want to take a look at that and see what we're doing. We're kind of like going an alternate path for backend search, because instead of, we did the ingester search, like that works well. We kind of maybe want to try something a little bit different for the backend. And so that's linked in here. I'm not sure what else we want to go through and talk about on the PR, but we just thought that would be interesting to link if you want to look through it. So what we'll do is we'll be working independently on backend search and then kind of like pair up the two efforts in the middle. All right. Cool. The last kind of feature that we wanted to talk about in 1.2 was there's a new Tempo CLI command. So I'm not sure if you've used the Tempo CLI, but it has kind of like a variety of like debugging or other commands. And what makes it different is that it has a lot of things that work directly against your backend. So if you're storing your blocks in S3 or GCS, you can run the Tempo CLI command or the CLI directly against that and do different things. So what we recently added was the ability to find a trace in the backend. And so this is kind of a debugging thing, but it might be useful for other things. If instead of calling the Tempo API, you can actually just point directly to the bucket and it'll perform all the same activity of finding that trace in the backend, downloading the Bloom filters, going through the indexes, reading the trace out of the backend blocks. And so it'll kind of tell you all the blocks that it's in, and the final output. So that can be useful for debugging, or I don't know, maybe there's like a cool data processing thing you could do with it. All right, cool. That's I think that's really all we kind of came with on the agenda to talk about. If there's any other questions, or we can talk about anything. Is everybody's Tempo install is going well? We can troubleshoot some issues if you have some, or just hang out for a minute.
I've been hitting, even with the latest version of Tempo, the ring problem with the compactor is unhealthy frequently, but I suspect that may just be due to using DNS as the ring on AWS.
You mean instead of member list or console?
Yeah, well, it's the member list, but it's being driven by A records within AWS. So I suspect it's probably related to latency there, but boy, is it frustrating, because you'll remove the unhealthy ones and the new ones will come up and they'll like catch some remnant of the DNS record or something before the TTL drops off, and then it just perpetuates.
So which version of Tempo is that?
I think I'm on 1.1. Yeah.
Let's see. I'm trying to remember what the most recent changes for that were. There were some Cortex
which is what,
updates that we did.
Yeah,
we haven't since then. Internally, we used to have the same issue. So every time we did a deployment, there may be a chance of a compactor becoming like an old one, unhealthy one, staying in the ring. But we haven't.
Oh, this isn't even on deployment. They just kind of randomly they get sick and just stop responding or something, and then the whole ring goes unhealthy. It's the one on my Kubernetes deployment is going good, so we're just waiting to shift to that. But
oh, I see.
But,
is this on Fargate or these other ones?
Yeah,
Kubernetes.
Yeah. Oh, Fargate deployment it's a little frustrating on the way the ring works. Yeah. So eagerly looking forward to getting off of that deployment. I'm sorry. I will step aside to allow someone else there.
Sure. Yeah. Go ahead.
Sorry, this was kind of tying into what you were discussing. So we have the same issue with the compactors on deployment. The same issue as you, Marty, I believe, where after deployment, old compactors are still in the ring marked as unhealthy, and then we have to go and forget them manually. So we're building automation to kind of like do that automatically. But you said that you fixed this issue. We're on like a pre-production. We're like building our own off of the main branch right now to try to get some of the early search features. But like we're still having the issue with like this.
How many compactors generally? Like what's the size of
that stay unhealthy, or that are?
Oh, just total. I think we have 40 or 50 compactors. I'm just curious.
I think we're running 30 in each cluster.
In using member list?
Yes.
Yeah. So I think what we had settings that were working well for us internally, and I think we made those the default member list. So out of the box, there are certain things in the member list code that we're using that aren't enabled, but they work well for us. And I think we had Tempo set those by default. Maybe what we can do is share those in the Slack. We can look those up and share, kind of like there's different settings for tombstone propagation and other timeouts and things.
Okay.
And so, let's share those in the Slack, in the public Slack. And maybe you can double check and see if you're overriding any of those or compare your settings.
Yeah.
We can kind of go there. Yeah,
that would be awesome, because I know we try to track like the default settings when they change from Git and make sure that we're either at like parity or like larger if we need bigger. But like I think for member list, I'm not sure we have a lot of things that are tweaked right now.
Okay. Well, hey, here's this link here. Thanks, Conrad. So the default's there. So that documentation should be created from like the manifest is created from the code. So hopefully that'll be correct, but maybe take a look at that. And we can dig into it if you want to reach out to us and see. We'll keep digging. Yeah.
That sounds good. I know Tanner had mentioned something a while ago. I think in Slack, it's just like we're there's other things that come up also. But yeah, this is great.
I think it was all in 1.1. There was an actual bug in the member list code that had to do with tombstone propagation, where it would just keep, if a tombstone came along with an update, it would just keep propagating it. But I think that was in 1.1. I think that's the latest. I don't think we have anything.
Yeah, I think we fixed it
then.
in 1.1. Yeah.
Okay.
Yeah.
Because we waited with 1.1 until it was fixed.
Yeah. And so otherwise distributors or ingesters are okay? It'd be interesting if they were working, but compactors don't.
Distributors are okay. Ingesters were having a weird issue where really unfrequently we'll have an ingester that gets stuck in crash loops forever. And the only way to get it fixed is to delete the PVC. And then it comes back correctly. But I think it's kind of disruptive where it'll happen. 2 ingesters will get into the state, and like the volume that we're able to accept drops significantly at that point, and it requires manual intervention right now. So I don't know. We're also building automation to kind of help with that right now. I don't know if you have any. I don't know if this has happened to you as well.
I'd be interested to know if the crash loop is maybe a bug or something. I mean, but there are other things that will look like a crash loop, like a bad configuration will cause the pod to exit and kind of look like a crash loop.
They repeatedly, basically. And yeah.
Yeah, ingesters can use a lot of memory. They store all the traces in memory for a certain period of time. And I mean, I think ours have like 10 or 15 gigabyte pod limits, which is pretty hefty. But there are some settings maybe you could tweak if your workload's a little different, like maybe flush them from memory a little bit faster if you want to kind of use less memory, but it would increase disk IO. That might be an option. Yeah.
Okay. Awesome. This is good. Thank you.
Cool. Yeah. Okay. So we have Edinardo says we were randomly seeing the following error. Let's see. Unable to find meta during compaction. So what that normally means is a different compactor got to that block first. Because what happened is it found the block that it was a live block, and it was going to, or it was up for compaction, it was going to compact it, but by the time it got to it, the metadata was gone. So either there's something else compacted it already, or maybe the block was deleted out of the bucket. So if the block was deleted out of the bucket, it's possible that maybe the retention period for the bucket is kind of conflicting with tempo zone retention. So I think we recommend like put it a day out. Like you can have like an S3 lifecycle policy, kind of clean up, to make sure the bucket doesn't have any stuff left over. We usually say maybe if you set tempo to 2 weeks, set the bucket to like 15 days, right? Something like that. So there's a little bit of a buffer. Otherwise, I don't know. I would look in the compactor ring and see if there's any unhealthy entries, or just make sure everything else looks good, and see if there's maybe compactors that are thinking they both own the same part of the ring. That would be something to look into. Yeah, I can't remember if there's anything more specific about that. I mean, it's not. As long as compaction seems like it's working, it's probably okay. I mean, the compactor will try again. I mean, every, I think, 30 seconds or so. It's kind of like looking at the block list and finding more opportunities to compact. So if it misses it once, it'll catch it on the next one. Okay, so this is something else in 1.2. There are a little bit of changes in this area that makes compaction a little bit more critical. So they will also, if you're running in distributed mode, the compactor will also be building the tenant index. And that was actually, part of that was in 1.1, but I think, and then in 1.2, we changed a little bit more where we're sharding across compactors. So it's important to have healthy compactors. Yeah. All right. Cool. Anything else? I guess we could wrap up a little bit early. Yeah, we can do that. All right. Thank you everyone for coming. This is good. These questions are great. I love hearing all the ways Tempo fails. Like, let's make it a better thing. So let's keep working on it. So that's great. And if we can't fix it, we'll keep trying. So Cool. Yeah, so just to recap, 1.2, we're kind of targeting by the end of the month, so that's in a couple weeks. And it'll have all these things we talked about. Yeah, cool. And Observability Con next month, so don't forget that either. Cool. All right, thanks everyone. All right, take care.
Thanks, everybody.
Bye.
Bye-bye.